Eric Burgess here, and we've been told to use the data to construct a box plot, check for outliers, and then we're given some data. So in order to construct a box plot, the first thing we need to do is to make sure our numbers are in order, which they are definitely not in order. So we're going to go ahead and go through and do that first. We need the number 16. That takes care of that one. There's another 16 over here. And then looking around, looks like 18 is the next one. After 18, we've got 22. After 22, we've got 23.5. After that, we've got 25. And then we've got 27.1. 32.5 and 35.3. If you have a lot of numbers, you can enter them in the calculator into a list, and then you can use the sort command to automatically do this for you. So if you have a lot of numbers, I would recommend that. As long as you make sure you enter them in accurately, you could still make mistakes. So now that our numbers are in order, we can go ahead and begin to look for the things we need for a box plot. So for the box plot, we need the lowest number. This is also called the 5-number summary. We need the first quartile, the second quartile, which is also known as the median, the third quartile, and we need the highest number. So the lowest and highest are easy. We already found them. They are 16 and 35.3. For the first quartile and the third quartile, we need to find the midpoints first of the data set. We need to find where the middle is, which is called the median. So to find the median, let's look at how many numbers we have, if it's odd or even. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. Since we have 9 numbers, there'll be an exact middle. It'll be whatever 9 is divided by 2. And so if we divide 9, let's just pretend that 9 is 8. It would be 4, right? And you add 1. So the 5th number will be the middle. That's how you do it if it's an odd number. If it's an even number, you'd have to average the 2 middle numbers. You can also do this visually. For example, if we highlight 1 on this end, and then we highlight 1 on this end, and then we highlight 1 on this, and then we go the other side. We just keep doing this one by one. We'll dial in on the middle. And as you can see, 23.5 is the middle. So because that's the middle, that's also the quartile, 23.5. That's the second quartile. It's the median. So now to find the first quartile, these numbers will form the numbers that we look at for the first quartile, and these numbers will form the numbers we look at for the second quartile. Because we had a number in our data set that was exactly the median, we don't include that number. If we had an even number and we had to average things, we would break the two numbers into the two halves. So that'll be covered in another case. So looking at this, for our first quartile, there's 4 numbers, and 4 divided into 2, right, because we want the middle, is the second number. But we see that we actually have to take the second and the third number and find the middle in order to get the true middle. Because if we were to do our method again, this time I'll maybe circle them in green. If we were to go one and then the other, we see that if we do one, we have to do the other. So there's no actual middle in this one. There's no number that corresponds directly to it. So the first quartile, we have to use the midpoint formula and take the middle 2 numbers. So 16 plus 18, and then we have to divide by 2. So we're going to take 16 plus 18 and then divide by 2. And we get 17. And on the other side, it's going to be the same since both sides have the same amount of numbers. So we're going to take the middle 2 numbers, 27.1 plus 32.5 and then we're going to divide that by 2. So we have 27.1 plus 32.5. Then we divide by 2. And we get the middle of 29.8. So this is just the midpoint formula. And don't forget to use parentheses. If you don't use the parentheses when you write it, you'll get an error with the order of operations. I entered it in the calculator so that I did them on separate steps, which is kind of the same thing as doing the parentheses. So now that we have our 5-number summary, we can do a box plot. So the box plot is going to have the lowest value on one side, which is, in this case, 16. And it's probably a good idea to establish a scale. So I'm going to count by 5s. So this is going to be 15. This is going to be 20, 25, 30, 35. How big your scale is will be dependent on your data. So notice our biggest number is 35.3 and our lowest number is 16. So I chose to count by 5s. But sometimes you might count by 100s, you might count by 10s. It's going to change. So our first value is 16. That's going to go right here. So I'll do this in red. We've got a 16. Our next value is the first quartile. That's 17. So it's really, really close. Actually, I can do this right on it since we counted by 5s. This will be 16. And this will be 17. All right. And I'm going to write these numbers a little higher. You'll see why in a second. 16, 17. Next, our quartile, the median, 23.5. So 23 is right here-ish. 23.5. This is our second quartile. This is our first quartile. And then our third quartile is 29.8. That's going to be close to 30. This is our third quartile, 29.8. And then our highest value is 35.3. That's going to be just past 35. Right here. And this is our highest. So you could put highest underneath and maybe lowest for the 16. So the reason this is called a box plot is because on the first quartile and the third quartile, on all the quartiles in the second quartile, we draw a box. You draw a line through each of them, and then you draw this box. So there's our box, and it has these extensions out to the lowest and the highest values. So we need to determine now, so this is the box plot, so we're all done. We need to determine now if there are any outliers. If there are, then we need to adjust our data. Most classes, though, have you just draw the box plot and then point out if there are outliers. They don't make you redraw the box plot. So because that's how Citrus College does it, I'm going to be following that way of doing things. But if you did find an outlier, you should really remove it and then redraw your graph. So let's go ahead and check for outliers. So there is a way to do this. It is the outliers are defined by a fence. So if they're past this fence, then they're considered an outlier. And we can have numbers that are too low, and we can have numbers that are too high. So we have to check both. Just looking at this, I don't think we'll have any, just because we're pretty close to the box on both sides, but let's check anyways. So we've got outliers, and we're going to use a lower fence. So a lower fence, that's going to be equal to 1.5 times the interquartile range minus Q1, our first quartile. So this is going to interquartile range is the length of the box. It's the length of the quartiles. So that's going to be, if we start at quartile 3, we're going to go to quartile 1. So the interquartile range is going to equal quartile 3 minus quartile 1. So you could just memorize that if you want to. So this is going to give us numbers that are too low. If they're lower than this lower fence, then they're too low. Up next, we have our upper fence. And this is going to be 1.5 times the interquartile range. And then we're going to add quartile 3. This will tell us if a number is too high, if it's bigger than this fence. So let's find these fences. The lower fence is going to equal 1.5 times, and we need the interquartile range. That's going to equal 29.8, that's the third quartile, minus 17, whatever that is. 29.8 minus 17. And we get 12.8. So this is going to be 12.8 times, or minus, 17. So let's go ahead and find this. 17 because that's the first quartile. 1.5 times 12.8 minus 17. We get 2.2. So there's no numbers that are lower than 2.2. So there's no lower outliers. Some people like to draw a fence at the value 2.2 if I just said it was way out here. So there's nothing below that. So we're totally in the clear. For our upper fence, we have 1.5 times the interquartile range 12.8 plus the third quartile, which is 29.8. This is going to be 1.5 times the interquartile range 12.8 plus 29.8. This will say if a value is too high. 49. We don't have any values 49. 49 would be like way up here, right? It'd be really far away. So if you could kind of tell that there would be no outliers here just by looking. Another way to think about it is if we look at this, we started at 16 and we went up to 17, which would be like this much of our data. And then we went from 17 up to 23.5, which is this much of our data. Then we went from 23.5 up to 29.8, which is this much of our data. And then we took from 29.8 onwards. And so you could think of this as the first quarter, the second quarter, the third quarter, and the fourth quarter. So this breaks our data up into different ranges. So if one range is really compressed, if the box looked like this, and then all of a sudden it was really long, this would tell us that our data gets really spread out for some reason after the median, but it's not very spread out near the median. The numbers are close together, or below, right below the median. And then if we had values that go out like this, maybe really far, that could be evidence that we have an outlier. Something's really far away from what is the middle 50% of our data. So looking at a box plot allows us to very quickly assess how our data is spread out and if there's some weird trend going on in our study perhaps. If you have any questions about this, feel free to drop a comment down below, subscribe and hit that bell icon for future videos, and we'll catch you in the next problem.